needed for data scientists. So far, we have seen NumPy array as the most efficient and most powerful tool for data scientists. We have seen that it is not flexible as compared to lists, but it is quite efficient in terms of memory optimization. It does not store redundant info. It has a fixed data type, and it has wonderful functions which you can use to manipulate data. So let's look into NumPy arrays in a much deeper way. We're going to see the basics of NumPy array and NumPy array manipulation. So the things we're going to learn in this particular section is that we're going to learn about the attributes of arrays. We're going to learn about indexing of arrays. We're going to learn about slicing of arrays. I hope you are familiar with the concept of indexing, slicing from Python section when we were talking about strings and we were talking about lists. So it's the same concept, and we're going to apply the same concept to the arrays. And lastly, we have the reshaping of arrays and broadcasting as well. These two concepts are a bit complex because we have to understand the orientation of arrays, we have to understand what are dimensions, what is the shape, and how are they related, and stuff like that. The first thing we need to understand about an array is that it has three attributes. Number one being the dimension, the shape, and the size. So every array has these three attributes. It has a particular dimension, it has a shape, and it has a size. So let's talk about these three concepts. So different dimensions of an array, what we mean by that is we have seen 1D arrays and 2D arrays so far. 2D arrays are matrices and 1D arrays are just simple lists. We also have 3D arrays, but that is where it gets confusing, because whenever it comes to dimensions more than 2, it becomes difficult to visualize them from a human's perspective, because we are not comfortable and we're not really suited for visualizing numbers in the third dimension as well, especially when we're talking about concepts and we're talking about numbers which are easy to visualize in a 2D plane. So the shape of array, this concept is rather simple as compared to the dimensions, because we're talking about dimension, row, and columns. So including the dimension, the other two attributes which define the shape of the array are the rows and columns. So these three particular things ultimately define the shape of the array. So I have used the round bracket for this, but it is actually the syntax. Whenever you will be reading the shape of an array, you will see that the output is always oriented in this manner. Firstly, we have the dimension, a number of dimensions, we have the number of rows and the number of columns. So the shape of every array has these three attributes, and they're showing the number of dimensions, rows, and columns every other time you want to print it. So the size of the array is the multiplication of the number of dimensions, rows, and columns. So it will all make sense once we get to the code and we start visualizing it. So this is the first code. So what we're doing here, we are creating an array of random integers. We have 10 random integers, and the size of those are 3, 4, 5. So coming from the, you can say that the concept we have just studied, if you just forget about that and we initialize these values to the x3, now you want to read these three attributes of dimension, shape, and size. What you're going to do is we're going to access and these attributes, and dim is the dimension, number of dimensions, x dot shape is the shape, and the size is the dot size. Now we're going to print these three attributes and see what we get. So the dimension is 3, and the shape is 3, 4, 5, and the size is 60. So the concepts we've just studied are actually proven with this code. Now you can see that the size, you can say the initialization of those values are in the same way we have studied, which define the shape of the array. So the first attribute would define the number of dimensions, the second one the number of rows, and the third one number of columns. Now we're going to see a different or a rather difficult concept. As I told earlier, it's rather difficult for people to visualize 3D arrays and how we're going to initialize them in NumPy arrays. So this particular code, and we need to study this even more carefully. First of all, we're going to count the number of square brackets. The outermost square bracket, obviously we're talking about the larger matrix, so forget about that. So the inner square brackets, we have 2 outermost square brackets apart from the outermost, and we're going to define two different matrices. So if you remember the code from 2D matrix, we have done the same thing, but we have repeated it in a larger square bracket. So this tells us that we have two 2D arrays, okay? And now we're going to stack them together. You can see that they are stacked one behind the other. And this is what gives it the third dimension. Let's deeper into the concept of dimensions. The best way to learn about this is to try different codes in Python and run them and to see what you get. So the first one is np1s. We are going to initialize it with the number of the rows, columns, and dimensions. So now there is something interesting about this. You can see it's quite obvious, and you should question yourself over here, is that the first value is not the dimension as we have seen before. And now this is something we need to understand about different functions. This function we saw earlier is the random rand int. And when we were initializing the dimensions, shape, and size, we used the size attribute and equated it with those values. Over here, we're not doing either of that. So I would highly recommend that you go on the collaboratory notebook and you try this out. You try what different values there are and why is this different. Although these are correct, there's nothing wrong with the syntax over here and nothing wrong with the syntax we saw earlier. But in order to dive deeper into the syntax, you should try it out. That is the best way to learn. But over here, we're going to talk about dimensions, rows, and columns. We're talking about the third dimension, I mean the 3D. When we're talking about 3D dimensions, you can say that it is oriented into both the 2D or the 4D. You can say that the 4 rows or 3 column matrices are stacked together, and the number of them is stacked together would be the number of dimensions. So if we have 2 dimensions, we would say that we have 4 rows and 3 columns, and there are 2 of them, which means that we are going to stack them together. The same goes with the other 2 functions as well, these np0s and np.random.random. But now the question is, why do we need such orientation of arrays? It's in what particular concept or in what application do you need these types of arrays? It's simple, we need them in images. So in images, we have 3 channels, the red, blue, and green, and these 3 channels combine to form different colors. So we are talking about 3 channels, which means that these are 3 dimensions. Previously, we saw 2 dimensions, and now we have 3 dimensions, which means that we have 3 of these channels, and each of them will have number of rows and columns, and we're going to stack them together, representing 3 different arrays with different values which are associated with them. The red, blue, and green channel. And we call them the RGB images, as you might have heard before. Okay, so let's move on to another concept of array indexing. We have seen this concept before, and we know that the overall concept of indexing is the ability to access different values of an array. As we access different values of a list, they are associated in a sequence, and that sequence has different numbers to every position in that array. So there are going to be simple indexing, there is negative indexing, and there is 2D indexing. So let's talk about simple indexing. It is a simple array which will have starting position from 0 to the ending position, which is the -1 size of the total array. So it's quite simple. We start from 0 and we go to the very end, and in order to access any value, we're going to use square brackets, and we're going to use integer numbers to access those values. So the negative indexing is a rather difficult concept because you need to imagine that every negative number starts with the ending array. So in order to understand it more easily is that if the first index value is 0, so the value before that should be the ending value of that array, and it should be -1. So in order to visualize it, if x1 0 is 5, so x1 -1, which should be the number before 5, is wrapped around the last value. So the 9, which is the last value, is also the number before 5. So if you can visualize and understand that, negative indexing is nothing but simple indexing. So we're just going to use the wraparound function, and we're going to see the -1, and we're going to see that it lies before 5, which starts from 0, and we're going to move on to -2, which is 7, -3, 3, and -4, and so on. So this becomes rather easy, but mostly you won't be in practice. It's not very common to use this because it gets rather confusing. So people keep it simple and use simple indexing and rather not go to negative indexing. So let's talk about 2D indexing. In 2D indexing, we have rows and columns, and every row will start from 0, and to the end of column we will call it, let's say in this particular case it will be 0, 1, 2, 3. If you want to access the first value, which is the value of the first row and the first column, we will use 0, 0. And in order to move across these in different columns, we're going to increment the value followed by the comma, and we're going to increment those values, and we're going to see that this is going to enable us to read different index values. So it's rather simple. It is just how we are going to use different values. So the first value should be 0, 0, that should be 3, and the last one should be 2, 3. So if we see that if we want to combine both the concepts, in this particular example, the line number 12 shows that the x2 value, which is the second row, and if you count, the second row should be the last one, and the column should be the first, which is the 0, the value should be 1. Exactly. And you can also combine both the concepts of negative indexing and simple indexing, but it's rather confusing, so don't go into that if it's absolutely necessary. But for the sake of this course, it's important and it's a good opportunity to learn it, and we will see that we can try different iterations, we can try different values to see what we learn in different indexing.